Welcome, everybody. My name is Stephen Feuerstein. I'm the developer advocate for PL SQL at Oracle Corporation. With me is...
Hi, I'm Chris. Hi, you're waiting for me to introduce you. So I'm Chris Saxon. I work for Stephen, and I'm also part of the answer team on AskTOM. My focus is SQL, so we're here to help you get the best out of Oracle database.
So Chris has his focus is SQL, but he's really good at PL SQL too, and he's way better at SQL than I am. So I thought, in case we have questions coming up that I can't easily answer, I hand it off to Chris. So again, thanks for joining us. This is our first PL SQL 101 Office Hours, part of our new AskTOM Office Hours program, in which we offer online access to dozens of database experts every month on different topics. Ours is on PL SQL and also on SQL because you can't separate the two. So one of us will be keeping an eye on the chat line. Another will be talking about PL SQL, answering your questions. We'll be doing it through the chat line. So click on chat, type in your question there, and we'll answer it. We'll keep everybody muted in the meantime. So just quick.
So Stephen, we've already got a question come in. So we got Phallic asking, how can I debug PL SQL code? Which is
a great question. Before I do that, though, I just want to go over some of the aspects of the
okay, sure.
Thanks. So we'll be using Zoom. Hopefully, obviously, you're inside Zoom. You're all configured. We're not going to be taking questions about bugs and SRs and licensing issues you might have. We're going to focus on the technology and how we can help you get better at using the PL SQL language and SQL and Oracle database. All right. So what I wanted to do, so Phallic, we can come back to your question, though this is not a session on SQL Developer, and that's where you're most likely going to want to do your debugging. And I'm not that expert in being a debugger in SQL Developer. Chris might have more experience there. But what I thought I would do with this session is first start off by talking a bit about PL SQL and block structure. And then we can take questions on that or broaden it out to whatever you want. So what I thought I'd do actually is use Live SQL. Hopefully, a lot of you are aware of Live SQL. LiveSQL.oracle.com is a place you can go to try out SQL and PL SQL, both to learn the languages, to try out different capabilities, and also to use the code library to run other people's code. I have, for example, about 140 scripts on PL SQL here. And one of the things I did was put together one on blocks. So there's no question that PL SQL is a very powerful language, but it's also one of the things I like about it best. It's a fairly simple language. Rather than give you a lot of complexity in terms of figuring out how to build your APIs to your database and take care of your data, we keep things relatively simple. And the core aspect of the PL SQL language is the block. It's the building block, you might say, of PL SQL blocks, PL SQL programs. They can be very simple. So you can see here the simplest block you can imagine. It does nothing really, really well. We can, of course, do more than that. We can say display world. It's essentially the executable section. But blocks can be much more interesting. So roughly speaking, blocks can have a declaration section, an executable section, and an exception section. And it's key for you as a PL SQL developer to use the language effectively, to understand both when you need these different sections, when you need an anonymous block, a nested block, a stored program unit. And these are all things we can talk about today, or again, answer other questions. So just to run through a couple of other elements of the script, which you can run yourself at any time. Here's an example of a block with a declaration section and an executable section. As you can see, it's a very readable language. What's the declaration section? It starts with declare. Where do my executable sections begin? With begin. So I can declare a constant or a variable and reference that in my executable section. I can also add an exception section. So here I'm saying if something goes wrong, look for exceptions of the value error sort. That's a predefined exception. And if I have that error, which I do in this case because I tried to stuff too big a value into too small a container, it raises value error. We handle it by displaying a message and then re-raise the exception out. And as you can see, we ended up with an unhandled exception. Now, just to get into a bit more interesting aspects of blocks, and then I'm going to open it up for questions. You can also have nested blocks. So within any block and around any single or multiple executable statements, you can create your own begin-end block. This is called the nested anonymous block. And you can go crazy with it. I once had an email from a reader a long time ago asking me, before I get started writing my next application, I just want to make sure that in your book you say to put a begin-end around every single statement. No, don't do that. So the question is, when would you want to use a nested block? There are two basic reasons. One is you might want to defer when you declare variables, both because you want to limit how much memory you use, but also you may not need them until, you might not want to have them declared up front until you need them. So for example, in a lot of people's code you might see, and you might see in your own code, and I see it in my own now and then, a long list of declarations, 5, 10, 20, 50 declarations of variables in an enormous program. And you declare something way at the top, let's say on line 55. You never use it until line 600. And by that time, it's totally out of context. How is this declared? How is it used? So that's what you see here. Multiple declarations at the top. But I don't use lmessage2 until pretty far down. So what I could do instead is do essentially just-in-time declarations. So now I declare my lmessage at the top. I use it in the main block of code. But right down here, when I'm about to use lmessage2, I use it in a nested block. I declare that variable, I use it, and then I discard it. It's gone. So you can basically scope down the declaration of those variables to just when you need them. And it'll make your top-level declaration section much cleaner, easier to read, less intimidating. The other main reason to think about using nested blocks is to narrow the propagation of exceptions. So again, if I have a nested block or any block, I can have a declaration section and an exception section. So in this case, what I've done is down in this lower section of my executable section, I'm doing an assignment. But if something goes wrong with that assignment, for example, if I try to stuff too big a value in it, raises value or exception, then what I can do is narrow the propagation of the exception, trap it, and then do whatever I need to do, and then I can allow the process to continue if that's what I want. So by creating that nested block inside my anonymous block or my stored procedure, I can grab that exception before it goes too far and shuts down the entire block, do whatever is necessary, and then continue. A very common example of where you might do this is with a select into. I do a select into, it might raise no data found, but I don't want to stop the whole block at that point. That just means I don't have what I need. I'm going to create a new row, whatever the case might be. So I trap no data found, take my action, and then continue. All right. And just one final point, then we'll go to some questions. What I like to do in general is not use nested blocks. They are very useful in the ways I just mentioned, but what I tend to do is create a nested subprogram. Here's a procedure inside my block. So you can declare variables, constants, types, etc. in your declaration section. You can also declare other subprograms, procedures and functions. You can't declare a package. You can't declare an object type. You can declare a procedure. And we're going to mute. So in this case, what I've done is taken all the code that used to be in a nested block. I've put it inside its own procedure. And then I replace all of that code with that procedure. And one of the reasons I like this a lot is that it keeps my main executable section smaller, easier to read, easier to maintain. And then if I need to get information about what this step is, I can drill down into it and explore the details, do my debugging, whatever the case might be. So I tend to keep my main executable section small and have them read like a table of contents. First do this, then do that, then do the next thing. Other people, like Bryn Llewellyn, who's the PL SQL product manager, doesn't like nested subprograms so much. He likes the nested blocks. And we can get into a discussion about what the differences are between those two and why you might have a preference in just a moment. But what I'll do now is stop my talking, turn it over to Chris to see if you've got anything you'd like to add, and then we can take a look at some of the questions we've got.
Yeah, I'd just say I'm not too much a fan of the nested subprograms either. I think kind of relating to Falik's question about debugging PL SQL code, because you can't then call them directly. It means you can't then test that individual unit effectively. Whereas if you've got a package and you make that subprogram a procedure within the package, you can call it directly and do whatever tests that you want on it. So that's kind of why I prefer that approach.
I have an answer, but I think before I'll answer that.
Go on.
We can have a great conversation about PL SQL, and hopefully they'll love it too. And we can go over to the questions. We've got lots of time. So that's a great point. And it's true not only for nested subprograms. With a nested subprogram, the only place you can see this is inside the bigger block, whether it's another procedure, function, or anonymous block. So it's true, you can't directly call it outside of this context. The same is true for private programs in a package. If it's private, I can't call it from outside the package to do my testing, which is something that people have commonly raised concerns about. And there are a number of techniques to address that as well. Here's the point about the nested subprograms. They don't make sense outside of this context. So you're right, you wouldn't be testing it individually, but it doesn't make sense to try to test it individually. It's a part of the larger whole. So if it's a nested subblock, you couldn't test it directly. And the same argument would hold for the nested subprogram. It's only making sense within context. If you're creating these massive subprograms, nested subprograms that really have a life of their own or should outside of that context, then it does make sense to move them out. So what you need to do when you look at any of the code you're writing, whether it's a nested block or just a bunch of code, you might say to yourself, I've written something like this elsewhere at different times, or I think I might need this again in the future. If it seems like a generic piece of logic, pull it out, make it its own subprogram, whether private or public, and then you've taken a step towards expanding its scope and making it available. But for nested subprograms, I would agree, you can't test them, and you don't want to test them independently. Okay. Well, let's see. So first of all, how can I debug PL SQL code? I'd say the answer is the same as with most programming languages, with relative difficulty, and it's the last thing we like to do. So I think there are a couple of key aspects to debugging that are worth pursuing. First of all, a source code debugger, line-by-line debugger, which is built into SQL Developer. I actually use it very rarely. Chris, do you have much experience with the SQL Developer debugger?
I don't use it particularly either. I think it's something we're best speaking to Jeff Smith. If you want to know about how that works, then he's a good guy to collar about it.
So putting aside the UI that an IDE might provide that allows you to set breakpoints and drill down and go step by step, what do you think, Chris, are the key aspects to being able to effectively and quickly debug your code? Because I would say there's one question of how to do it. The other question is, how do we be most productive about it? Because we don't want to have to spend a lot of time just going through our code line by line to sort it out.
I think one thing is just to try and keep your procedures and program units small. It's kind of like you were just saying about if you've got this massive ongoing block of code, if you get an error or it can't compile or some reason, it's tricky to figure out exactly what's going on. So if you've only got 10 lines of code, narrowing down exactly where the problem occurs is much easier than if it's 100 lines long. So making the chunks of work as small as possible is a good way to help identify any problems and then test what they should and shouldn't do.
And I think when it comes to debugging, it comes into the similar vein as how do I effectively test my code? And that's a whole big topic all by itself. But the reason I mentioned it is that the first point you raised, I think, is the most important. Most of us write code that is really hard to test and really hard to debug because it's just this endless blob of code that has very little structure to it, very little modularization, which makes it, and also a single procedure might try to do too much. So for example, if you have a procedure that needs to update 15 tables and modify the package state across 25 different variables, having one program unit that does that means that you have to build an enormous number of test cases and more complex debugging to sort out what's going on. If you break it up into smaller pieces, then you can test them and debug them individually and make it much easier to manage that code over time. Now, the other aspect of debugging that I would talk about, it's not exactly the same, but it's related, is instrumentation and tracing. So I think that the best bet you have at writing code that you can debug relatively easily, which means, what caused the bug? Find the source of the bug and fix it, is to put tracing in your code so that when something goes wrong, you can turn on that tracing and get information about what's going on in your application. And why don't I go ahead and I'm going to see about switching over to SQL Developer and share some of my code, and I can show you what I do in terms of tracing.
Yeah, just while you're doing that, I think that's a great point, Stephen, about instrumenting your code, particularly when you're doing more complicated things. I mean, a while back, I built a rather large dynamic PL SQL generator, and there was a lot of complex logic about figuring out exactly how to create the SQL statement in the end. And so I just had pretty much every line, tracing instrumentation so you could see what exactly we'd captured so far. This made it a lot easier to then debug and figure out afterwards. Particularly as then we'd log the SQL statement, so you could pull that out, run it in SQL Developer on its own, see whether it gave you the results you expected.
And that's great. So what you're seeing now, hopefully, is my SQL Developer session. And I opened up a package called the DG Class Manager package. It's actually the package we're using in the Dev Gym and AskTOM Office Hours to manage classes, manage the Office Hours sessions. And what you would find if you had access to my code, lots of interesting stuff. But you'll find lots of references to trace. So I have a utilities package. The QDB is the quiz database, part of the Dev Gym infrastructure. And then I have my trace activity program. I also have my trace is on function. So you'll see over and over again code like this. If trace is turned on, then trace the activity. I'm scheduling the webcast, here's the class and the parent, and then the details. Now, by default, trace is turned off. So this says no, and it doesn't execute this code, and then it continues on. But at any point, while I'm in production, and this is the key thing, when you're talking about tracing, it's got to be something you can turn on and off in production. Through the UI of my website, the Dev Gym, I can actually turn on tracing live. So if somebody's having a problem, we can actually start the tracing, gather the information, and then turn it off, and then analyze the results. Now, and just one other point about this, and we'll keep going on through the questions. Here's what you'll often see in people's code is something like this. Just trace the activity. Inside my trace program, I ask, is trace turned on? Without a doubt. So I do that. This will not automatically trace. So you might ask, why did I put it inside an if statement? And the answer is that one of the problems with tracing is that there's execution overhead. When I'm running in production and I have trace turned off, I want to have the minimal impact that I can on the performance of the application. So what I do is have a Boolean function that says, quick check, on or off. And then I have my code that does that. And then if it's turned on, then I go through the overhead of calling trace activity, and it will ask again, is it turned on? But here's the thing. When I just call trace activity like this, without the if statement, even if tracing is turned off, the cost of evaluating the parameters is incurred. And if I happen to call a function or a function inside my trace activity that might take a couple of seconds to run, it's going to be taking a couple of seconds to run every single time the user runs it, even if I'm not tracing. So I always hide my trace logic inside the smallest overhead Boolean check that I can do, and then incur the overhead if tracing is turned on.
So is that something you always do, Stephen, then? Because I typically would always just rely on the tracing within the package. Is that?
I always do this, yeah. So if you look across the Dev Gym backend, I never call trace activity directly. I always call it inside the Boolean. Yeah. And once you've got the pattern set up, either as a snippet in SQL Developer or obviously copy paste, it's not like it takes longer to write it. I never write this. I just modify this stuff, copy paste. But yeah, I pretty much always do it. Will it make, how much of a difference does it make? I don't know. It's hard to say. I haven't actually sat down and run through my tests. But here's the thing. I'm sure a lot of you remember Tom Kite. Those of you who have been around in the industry long enough. He is the guy who started AskTOM. One of the comments he made is that he's happy when the volume of instrumentation code, the tracing code, is larger than his application code. Now, I'm not sure if I'd want to do that because I've got a lot of PL SQL code. That would be an enormous amount of trace code. But the bottom line is that you shouldn't have to worry about the overhead of putting in your trace. You should overdo it. You should overtrace in the sense that the more information you can get when you've got a problem, the better by far. And so what you want to do is minimize that overhead. One of the other nice things about tracing is that you can always go back and later and put it in. It's not something you have to get done right up front and right the first time. You can always add more as you identify other soft spots or vulnerabilities in your code. Well, Chris, I've got a question here that I think I'm gonna hand over to you because it's not PL SQL, it's SQL. How do I eliminate nested outer join loops in SQL when it comes to tuning my SQL statements?
I mean, it's kind of a tricky question to answer in the abstract because you kind of really need to look at what. Well, the first question is, why do you think that's a problem? You know, are you just trying to eliminate it because you think it's bad, or have you truly identified that actually a different approach, such as a hash join, would be faster? And the fact that you're kind of saying a nested outer join loop suggests that you've actually got an outer join in your query. So if you don't want that, change your query to be an inner join, and then it'll be standard kind of nested loop. I mean, the thing is, the optimizer is very smart these days, and actually from 12c, it can decide on the fly whether to switch between a nested loop or a hash join based on how many rows it's processing. And it does this really, really well. So if you're on 12c and above, and it's chosen the nested loops, there's a good chance that that's what it should be doing.
Mm-hmm.
If it's on releases before that, you kind of got to ask yourself, got to look deeper into what it's doing. Are there actually better plans available, and how would you make those work? If you think it is bad and you can't get the optimizer to choose the more effective plan, one method we recommend using is something called SQL plan management. So there's two aspects to this: SQL profiles and SQL baselines. So a baseline says, I like this plan, we've got this good plan and we want to keep it and always stay with that particular execution plan. And the database won't change then. It won't choose a different plan unless you allow it to. So there's a process to enable new plans available. A profile is more like a very complex series of hints where you say, it tries to correct the optimizer's estimates about why it chose, an incorrect or a bad, slow plan, and it doesn't fix a particular plan, so it can still come up with different ones. So they work in slightly different ways. You can actually have both, so you could have two baselines, so two possible plans for a query, and then a profile to help it choose between those. But they say this is a very big and deep topic, and if you've got more questions, it's better to come up with a specific problem or a specific situation where you want to try and deal with this. So.
All right, thanks, Chris. I have to remember to unmute myself. Thanks for that. So we had another question having to do with package variables. Let's see if I can find my chat.
Yeah, so it says, what is the scope of package variable? Can I declare global variable for all sessions? And also explain OOP, so I guess that's object-oriented feature of PL SQL.
Yes.
Yeah.
So let's see, first of all, what is the scope of package variables? I'm going to do a little test first, which is to say, I'm going to go back to Live SQL. That was interesting. And I'm going to search for global. Let's see, global versus local variable. So I really encourage you to use livesql.oracle.com to explore SQL and PL SQL. We've put a lot of scripts in here, especially me. Let's see what global versus local variable. That's not even mine. So let's go back and check again and see if I've got one there. And then let's see if we can use this one, global versus local variable. Yeah, no, I guess not. Okay, so let's go back to Live SQL. There are lots of scripts you can grab. You can take a look at. But anyway, sorry, that's not going well. So let's talk about packages, local versus global. So essentially, when you declare a variable, it's declared within a scope. Let's go back to my Live SQL script. Sorry, folks. Block. Here I'm declaring a variable. We call this a local variable. Why? Because it's local to this block. When the block terminates, when that end statement is hit, all the memory for all the locally declared variables, types, cursors are closed down, memory released, which is really nice. So there's automated garbage cleanup in PL SQL, one of the really nice features of the language. Whether it's a stored procedure, a function, a trigger, or an anonymous block, all those variables are local. They disappear with that block. The exception is the package. So when I declare variables at the top level in a package, and let's go ahead and I'm going to go back to my SQL developer and show you that. Whoops. Am I not sharing it yet?
Yep, we got your SQL developer.
Yeah, okay. I don't see the green box around it. I'm confused. Okay, so here's the class manager package. If I go up to the very top of the package, generally speaking, this is where you'll find the globals, quote unquote. You see a variable, a couple of constants that are declared outside of any individual subprogram. So here's my first function inside my package. And if I look at the package spec, here are a number of procedures and functions as well. So that's the public API of the package. And at the top, you can see lots of different constants, which is a pretty common thing in my packages, probably in yours as well. So these are public globals. So they're called globals in PL SQL. Why is that? Because when you declare something at the package level, outside of any individual procedure or function in that package, then it has session state, which means once I assign a value to it, and once the package is initialized, the first time anybody in that database instance uses it, it's loaded up into memory. The first time I use it in my session, it's initialized for me. These values are assigned to these constants, and then they sit in memory in the process global area memory, ready for me to use. And they're not constantly reassigned. So in that sense, it's global across different server calls in my session. It's not global across multiple sessions in the database. And when the package is refreshed and the package state reset, then these variables are assigned their values, again, the constants and so on. The same thing, by the way, is true for cursors. So if I go back up to my class manager package at the top, notice I have a cursor. I declare the cursor here because I'm going to open it and reference it in multiple subprograms in my package body. Now, the interesting thing about a cursor is that when it's declared at the package level, if you open that cursor in a block of code, it will not automatically close the cursor when that block terminates. So cursors actually stay open across server calls, which could be great if you want it that way. Mostly it's not. And you mostly want to keep your cursors declared locally or make sure that they're closed when you're finished using them in that particular scope. So let's see. So that's the scope of a package variable. It's your session. It's not outside of your session. The other thing to remember is that in the modern world of stateless web applications, you should generally not depend on package state, not for anything that requires a lot of computational power. Using constants, having constants at the package level, no big deal. When the package is reinitialized over and over again, you're not going to pay much of a cost. But if you have an initialization section in your package, so if I go down to the bottom of my package, notice it simply says end. But what it could say is begin, do stuff when package initialized. And this program will run every time the package is initialized in your session. And when you're working in a web-based environment, that will run over and over and over again. So in general, in the modern web-based, mobile-based world, as opposed to like the client-server model, you want to avoid initialization sections in packages, I would say, and not pay for the cost of the initialization. So that's local versus global for PL SQL. Now, I think the question was also about going past an individual session. Is that correct? Can I declare global variables for all sessions? Chris, any thoughts on that?
I mean, it's kind of tricky. So if you're wanting something to persist across all sessions, then you're probably wanting to store it in a table or something like that, so other people can modify and manage it. I can't think of many instances where you have something which you only want to exist in memory and still be visible across multiple sessions, because if the last session finishes for some reason, then it's gone, and why did other people need to see that? You've got to go through the initialization process again, Stephen talked about. So in that instance, what you're probably looking at is storing it in a table somehow and then having some kind of API to that so other people can access and modify that variable.
And I think when you talk about global across sessions, it's worth remembering about roughly speaking, the different kinds of memory that you're working with. So when you're talking about session-specific memory, so that's for my stuff, what I'm doing or what my user is doing with my stuff, that's PGA or process global area, and there's a separate PGA for each session connected to the database. Then there's the SGA, the shared global area. And the whole point of the shared global area really is to share information across sessions. And because of the complexities of doing that, and also the importance of having data integrity of that data across sessions, that's something that's best managed by the database. As Chris said, one way that you manage data across sessions is you put it in tables and you have the whole persistence model and the consistency model that comes with relational tables at Oracle. But there are other things as well. So for example, there's the function result cache. The function result cache is a feature that allows you to avoid executing a function over and over again if it's being passed in the same input values over and over again. You can actually say, hey, this was called 2 minutes ago with input value 1. I've already got the return value. Just give them the return value. Don't execute the function. That cache of information is shared across all sessions, and it's stored in the SGA. So roughly speaking, I think the answer would be, if you want to share data across sessions, don't try to come up with your own mechanisms for doing so. Those days are kind of long gone. I started with Oracle in 1987, and back then we had many fewer tools to use. So one of the things we would do back then is use a package called DBMS pipe. And DBMS pipe allowed us to create pipes of data inside the SGA in memory. And we could use this as a temporary storage place to hand information between sessions. And it was fun, it was exciting, and you don't want to do that anymore. You want to stick with the built-in features of the database. Okay, hopefully that answered the question. Now, the follow-up part of that question was, can you tell us about object-oriented programming in PL SQL? And what I'd like to do is hold off on that one because it's a very big topic, and also relatively few PL SQL developers will ever benefit from it. I'd like to see if we've got some other outstanding questions that are a bit more focused on your day-to-day tasks in PL SQL. Yeah, so Chris,
go on.
I beat you to it.
Yeah.
Is anything inside a PL SQL block auto-committed? Does the PL SQL block have a SQL ID? Does every SQL statement inside a PL SQL block have a SQL ID?
Okay, so we'll start with is anything auto-committed? So the only time it commits is when your code actually has a commit in it. Now, one thing you do need to watch for is that some of the DBMS packages and so on, so if you're calling another person's code, and that includes some of the DBMS packages, they might have a commit within it. So there might be, this is where you need to be careful about how you build your APIs and how you access other people's code, because if they have some kind of transaction management, such as committing or rolling back, then you need to be fully aware of how that works, because that can break how your transactions work. But in general, there's not going to be an auto commit within the block unless you actually explicitly put a commit in there. I don't know if you've got anything else to add on that, Stephen, or...
So, right, so the main thing to remember is that in general, Oracle, the PL SQL environment doesn't commit or roll back for you. You have to do it yourself. You mentioned autonomous transactions as well?
I actually, sorry, no, I haven't mentioned autonomous transactions.
One thing to remember is that there's a feature in general, in your session, if you issue a commit, it commits all the changes in your session. If you issue a rollback, unqualified rollback, it rolls back everything in your session. So you as a PL SQL developer generally have that control, number one. Number two, you generally don't want to exercise that control. Usually when it comes to committing, you want to leave that up to the user to decide on the commit point. And again, within a stateless environment on the web, generally every server call has a commit that follows it immediately. So you don't even have the concept of a transaction in terms of the web application interacting with the database. Another reason to use stored procedures in PL SQL, you can bundle statements together and create the logical transaction that they will then commit. There are also things called autonomous transactions. So if I go back up to my live SQL environment, view all scripts, look for search. Autonomous transactions. Let's just look at a demonstration script. So if I declare my program to be Pragma autonomous transaction, then inside that program, if I make changes, I commit or roll back, and in fact, I must commit or roll back before the program terminates, and it will only save or roll back the changes within that single subprogram. So autonomous transactions allow you to narrow down the scope of a commit or a rollback. Something very important to keep in mind. And remember the trace program I showed you before, or I showed a call to it, trace activity, that's an autonomous procedure because I want to write to the log and then commit it without committing my business transaction, which might in fact have a problem. I want to log the information and keep on going without affecting the business transaction. And then of course there's DDL. So whenever I execute a DDL statement, if I say execute immediate create table, which you can do in PL SQL, you generally don't want to do it a whole lot in production apps. That will also do an implicit commit. But a Pragma autonomous transaction can also constrain the effect of that to just the program in which the DDL statement was executed. So in general, no auto commits. The transaction is managed by the user. You can override that. If you're doing a batch script, you might have commits. I do have commits in some of my code, but it tends to be rare and something to avoid. Genevieve also mentioned, I think in terms of the conversation about global versus local or passing state across sessions, she mentioned application contexts. But that's still within a session, so far as I know. You can create your own application context values that are specific to your session. There are context values that are global, like the user environment, but those come from Oracle anyway. So I'm not sure that, I think it's great to keep in mind that you have application contexts, which you access through the sys context built-in function. But I don't think that will help you in the cross-session kind of scenario. Chris?
Yeah, I agree. Like I say, it's just another way to kind of manage your kind of global variables. So I'm not aware of it being able to help you in the cross-session examples.
And here's a message that was actually sent to me privately, but I'll repeat it and see, Chris, if you have any thoughts. I don't. Is there any document you know which has peeled out every layer of functioning of the range windowing clause? How Oracle Windows using the clause, using the values of columns mentioned in the order by, et cetera. I need to study this document so I can learn about range. Any thoughts?
So studying how the range and the rows clause of analytic functions works, I don't know, other than, I don't know of a specific document that covers just that, other than what's in the document, what's in the docs. I will say that on Thursday at 2 p.m. UK time, I will be talking about analytic functions. So I'm going to be having a session on that. If you've got specific questions or want to know more about how that clause works, and please come along to that, and we'll handle the questions there.
Yeah, so I think that the bigger question is how do you effectively understand and use analytics, and Chris is going to be offering that. Connor McDonald also has a whole YouTube video series on analytics in his Simply Smarter SQL YouTube channel. And I suggest you check that out. And we'll be actually offering a class on the DevGym on analytics by Connor in the coming months. All of that should help. All right, other questions?
So should we go back to the ask after the auto committed? There was a couple of other follow-on questions about PL SQL blocks having SQL ID. So a couple of things I wanted to say on that. One is that, so every statement you submit to the database will have a SQL ID. And if that statement is calling some PL SQL, like a begin end block, or the call PL SQL procedure, that will have a SQL ID. But what you don't get with PL SQL is if that then calls another procedure, anything within that doesn't get its own SQL ID. So Stephen, on the screen there, you've got your local procedure, save line. Mm-hmm. That would not appear as its own SQL ID separately to what you've submitted there. This changes for SQL statements. Every SQL statement will have its own SQL ID, but PL SQL, it's only the actual code that you send from the client to the database. So from your application front end, so whether it's a Java or Application Express or whatever it is that sends it to the database, or you typing in SQL Developer or whatever your development environment is.
Great, thanks. Let's see, we've got a few interesting questions here stacked up. One of them is explain object-oriented features of PL SQL. That's a big one. We can come back to that and touch on it briefly. Also, we just had a question come in, explain pipeline functions. Is a pipeline function faster than a query from a view or a table? I'd like to talk about pipeline table functions, and I'll see if I can find a demonstration or an example to get to.
Yeah, so that's an interesting question. That's where you kind of, with a pipeline table function, you're defining how the rows are returned or what the data set is that comes back to the database, or back to the client, I should say. Now, in general, querying a table or view directly would be quicker because you're just invoking the SQL engine directly. Whereas if you write a pipeline table function, you're writing your own code, which is unlikely to be faster than the years and years of optimization that have gone into SQL and Oracle database. That said, there will be situations where there's something specific that you're doing about your database. You've got a specific user requirement where you want to pass data out, and in that case, it will be better. It can be better. So to do that, and I see Stephen's bringing up an example on the screen there. So do you want to kind of talk through about why you've done that and use that in that situation?
Sure. So in general, I'd suggest that you think about using a table function as a way to not to replace SQL or improve upon the performance of SQL, but to programmatically construct a data set. So I'd say there are roughly two different use cases, or there are a few use cases for table functions and pipeline functions. But one is you don't have a data set that you can execute via SQL. So it might involve literally constructing it on the fly with some complex logic in your PL SQL code. So you build out your data set, and here's an example of a function that returns an array. I've declared it to be pipeline, though table functions don't have to be pipeline. I'll come back to that perhaps. But the basic idea is that I construct rows of information, and then with a pipeline function, I pipe them back out. And then the query that calls this function can consume those rows and integrate them into the query. Or more generally, a table function returns an array. I can construct my collection. Notice I'm putting values in my collection right here. And then I return my collection. And the basic idea is that once you've got this function set up, pipelined or not, once the function is defined, then I can select from, or insert, here's an insert select from table of my function. And I can pass in parameters. In this case, I'm passing an entire select statement as a cursor expression into my function. So I might need to programmatically construct my data set, but I can treat it as if it were a table by saying select from table of this function, and it converts the collection coming back from the function into a relational table format. It doesn't create a table. It's just essentially a virtual table, a view. And the other approach you might take, and maybe I shouldn't say this, but sometimes we don't know how to write the SQL well enough to get what we need. Chris is really great at SQL. Connor's really great at SQL. I'm not that great at SQL. Sometimes I'll build a table function because I can figure out how to construct my data set in PL SQL faster and easier. No, well, faster for me, slower for the engine in PL SQL than to sort out the details in SQL. So I use the table function as a kind of fallback position to shore up my weaker SQL skills. Chris, you unmuted. Did you want to say something?
No. I was just I mean.
Okay. So going back to pipeline table function. So the table function is select from table of my function. The pipeline table function is pretty different and important in a couple of ways. When you pipeline, you're not building out your array and then returning it. You're sending it back. You're piping it back to the calling query with each row constructed. And the key thing there is that the query can utilize that data immediately. It doesn't have to wait till the function's completed. So essentially, asynchronous to the completion of the function, the data being returned by the function is being consumed by the query and used. So to make that really clear, I put together this little program. I'm not going to run it right now. I haven't actually run it in ages. But basically, I looked at the performance comparison of selecting from my non-pipeline and pipeline table function. And I said where row number is less than 10. So just give me the first 9 rows. And what you'll find, I should have some examples here. What you'll find is that without pipelining, it takes a much longer time to get that data back. Here's 100 times slower. This is back in Oracle 9i. The differences go down as the versions go up. But the bottom line is that pipelining was able to complete the task much faster than non-pipelining, because with a non-pipeline table function, when you call that function right here, the SQL statement stops, it's blocked, and the function executes, and when it returns control, the SQL statement can continue. With the pipeline version, with every row that it returned, the SQL statement could grab it, the SQL the select statement, could use it. And it said, wait a minute, I've got 9 rows. Stop. And it terminated the pipeline function execution. So that shows you the difference in behavior with the pipeline table function. And you can also parallelize this pipeline table function so it's running on multiple processes if you're doing parallel query, and achieve great improvements in performance. Hopefully that gives you a decent sense of some of the aspects of pipeline table functions. If you check out my blog, which is Stephen Feuerstein on plsql.blogspot.com, then you can read, I think I've got like a 5 or 6 blog series on that topic. Okay.
Okay. I just want to say, someone pointed out to me privately that there's the access globally option for application context, which you can use to see things across sessions. I must admit, it's not something I've ever had a reason to use. Like I say, I think in my experience, it's rare that I can think of situations where I want a global variable across sessions that I didn't want to store in a table or something like that. So, but yeah, that is available.
So many tricks and toggles and switches in the Oracle database technology, and that's why we're offering office hours. I had another question here. Using PL SQL, can we transfer text to the clipboard? Well, let's see. I think I'd answer right away 2 things. One is, don't do that. And the other is probably maybe, but I really don't think you want to do it. So obviously you're interacting far outside the database when you're talking about the clipboard memory in your computer. I suppose maybe there's a way to do it by doing a Java call, a Java stored procedure from within the database, but I sure don't know how to do it. And again, it seems like a very dangerous thing to want to start playing with when you're deep inside the database, right? PL SQL is not a general purpose programming language. It's not like Java or JavaScript or any number of other things. It's much more specialized. And you can usually make it step outside of its zone of comfort to get things done. But you really want to ask yourself, is that the right thing to do? Is it the right place to do it? And in general, I think you want to keep using PL SQL as that database API. You're building APIs on top of your data structures to control access to them and implement business logic. But don't go crazy.
Yeah.
Does it make sense to execute a PL SQL procedure in parallel? Sure, if you need to. So there are a number of different ways to execute things in parallel in the Oracle database. PL SQL in general is not, it's not a parallel, it's not a multi-threaded language. You can't run, a single session runs a single block of code at a time. You can emulate that with DBMS Scheduler. You could kick off 4 different jobs running at the same time, and they're all doing the same thing or running in parallel. So you can do that. There's also a DBMS parallel execution package for executing DML in parallel. So there are a number of different options for parallel execution. But again, ask yourself what you're trying to accomplish, and you got to think through the ramifications very, very clearly. If each one of those different processes running simultaneously, modifying the same table, you can end up with locks, deadlocks, latch contention, all sorts of problems. So again, ask yourself very clearly, what's the requirement? What do I need to get done? And then figure out the best and most secure way to do it. How do we put synonyms for package procedures or functions? I think what you're asking is, can I create a synonym on a single subprogram in a package? And if that's the question, the answer is you can't. You can create synonyms on database objects. So the package itself is the database object. You can create a synonym on top of the package. If you really want a synonym for just that single procedure, what would you do, Chris? You're muted.
Don't forget that I'm muted. Yeah, so there's a couple of ways you could approach that. If you just want to expose a particular procedure from a package, then you know, one of the most straightforward is just to create a standalone procedure that does that. You know, it calls that individual thing directly. Or perhaps you could look at how you're structuring the package itself, either by separating out into different packages what's in there, or by making the other parts of the procedure private. So it's, you know, I don't think there's a straightforward answer because one of the good points about packages is it helps logically group things together. So you've got code to manage customers, you can have a customers package and all that code goes together. Of course, at some point that package could get so big that it's kind of unmanageable. So you want to split it out and to do things like manage customer orders, manage their credit risk and various other things. So if it makes kind of logical sense to do so, to expose a particular procedure, then you might want to refactor your packages. If not, you could go and just create standalone things. I don't know if you've got any different opinions on that, Stephen, or?
Oh, that pretty well covered. And what I was actually thinking as you were explaining this, and we probably want to do this in our Q&A as I get better and better at it, is ask you why you want to do that. What's the use case? What problem are you trying to solve that you need to do this? And that would help us understand what the different possible solutions or what the best possible should be. So I'll try to get better at doing that. And if you want Thakran to indicate why you asked that question, what you want to try to do, we'll follow up. Here's another question, Chris. Can we have multiple exists in a single SQL statement?
Yeah, you can have multiple exist statements within a SQL statement. I mean, you can nest. You can have an exists within an exists within an exists. Although, kind of going back to Stephen's point about what are you trying to do? When you start getting into that kind of level of nesting, it gets really tricky to figure out what it is that you're trying to achieve. Particularly if you're combining, particularly when it gets to not exists. People really, or at least I really struggle with like negation. What happens when things go? You're trying to say this is not something, and it's tricky to flip that around and go, okay, that means it happens in these instances. So if you start nesting these things, you can perfectly do it, but it just makes your SQL more complicated to read, and it's worth asking, could you do it in a different way? For example, joining the tables.
So we'll be running out of time in a few minutes for our first session. Chris is doing his own SQL talk with Keith Laker, one of our product managers in the SQL team. And one of the things you might want to talk about there, or people might ask about, is the with clause and being able to modularize your SQL statements and do top-down design of SQL. It's an incredibly powerful feature. But before we finish up today, I had one question. How can I download the video of today's session? So the main thing to remember is the same landing page for AskTOM Office Hours. You can come back to this page later on, and you'll be able to watch the video from this page. So all you have to do is bookmark this URL, and you'll always be able to find out about the latest Office Hours sessions on PL SQL 101 and view the older sessions and the videos for them. So right off of that page. So let's see, I think the only outstanding question we have right now, Chris, is what about object-oriented programming in PL SQL? I suppose that's a fun way to end. So why don't I talk about it for a few minutes, and then we'll shut down and come back in a month. So let's switch over to SQL Developer. So a long, long time ago in Oracle 8, Oracle database became an object relational database. I won't go through the history of why we did that. Some people regret it. Some people think it was a great idea. But the bottom line is that you can create object types essentially like object-oriented classes using PL SQL. And they're called object types. So I create a type as object. Some of it looks like a table declaration. Those are my attributes of my object type. And then I can create members and functions and procedures within my class, within my object type. So for example, I'm creating a food type. I'm not going to go into lots of details here. And then I can create on top of that, so I can create hierarchies of object types, just like you can create hierarchical class structures. I can create dessert under food. I can create cake under dessert. You know what I like to do? I like to eat. So what I've done here is create a very simple type hierarchy in which I have the most general type of stuff of food. I have a more specific type of food, a dessert, because desserts contain chocolate, or they could. And I keep track of the year created. I add additional attributes on top of my original food. And then I create cake as a special type of dessert. So I can create these hierarchies. And then what you get out of it are pretty much the standard object-oriented features. So I have dynamic polymorphism at runtime. The Oracle engine will decide which of my different methods in the hierarchy to call. I have substitutability. Any dessert is a food. So anywhere I have a dessert, anywhere I have food, I can use dessert. But not every dessert is a cake. So if it's a cake, it can't necessarily be used as if it's a dessert, it won't necessarily be a cake. So all of those common ideas of object orientation are available in PL SQL, and I've definitely talked to developers who have written full-blown object-oriented applications using PL SQL. It's possible to do, and certainly as of 11G with some of the newer enhancements, like general subtype invocation, you can pretty much do what you need to do. Chances are you'll run into very few requirements for object types because most of us as relational developers aren't trained in object orientation, and there's the usual mismatch, impedance mismatch between object-oriented and relational. So the bottom line is you can do it. There are some examples that I gave you here, and I can, I'll see if I've got anything in my blog too about that.
Just wanted to say on that, one area where I have found PL SQL objects really useful to use is actually mapping to your middle tier language, typically something like Java. So they all have their object representation of a customer or something like that. And one thing that is I've seen and I've actually done that is quite handy is to load your data into a PL SQL object which matches the object or the structure of the object in the Java land. And then when it returns results to that client, they've actually got it kind of natively. They don't need to do any kind of mapping to convert it into an object. So that's, for me, the most useful or the most practical way to use OO features within PL SQL.
Great point. In fact, going back to pipeline table functions for a second, what you end up doing are creating nested tables of objects. And it's that same idea of mapping your data set. And there's specific reasons why it's done in pipeline table functions, but the bottom line is that you can pass back a row of information, which is actually the object type. And that's easier for the object-oriented clients to leverage that information. So great point. One more question, then I think we're going to close down for today. I'm a newbie to Oracle, and I have a bunch of materialized views written in the old join syntax. Should I rewrite these, Chris? Are they using indexes effectively? So do I need to go to those ANSI standard joins?
So you don't need to. I mean, you can use whichever join method you want. There are some features which don't work in ANSI, and there's some features which don't work in Oracle. Materialized views are one of those areas where ANSI standard joins are not fully supported. There's some features of materialized views that don't work either at all or very well with ANSI style joins. So if you've got materialized views in the old join syntax, then just leave it as it is. Any kind of indexing is kind of a separate discussion about whether or not that will work. But I just leave it. And I mean, I think unless there's a reason to change your existing code, I don't see a particular reason to change it. I don't know about you, Stephen.
No, well, you're talking to an old school guy, so I don't use ANSI standard joins. I still use the Oracle joins, and it's sometimes quite embarrassing, but I've come to live with my embarrassments. So I think the main takeaway there is don't worry about your indexing. The join approach that you use is not going to impact the performance unless you write it poorly as a result. So in that sense, yeah, don't worry about modifying the syntax of your statements. You might want to learn your ANSI standard format just so that you are using the newer approach. And that there are definitely some advantages to it for the new code you're writing. But as Chris pointed out, and I wasn't aware of it, watch out for using the materialized views. All right. Well, that pretty well closes out our hour. Thank you so much for joining us. As I'd mentioned before, bookmark this page. You can always come back here to check out the archived video when we have it up and running. Check out the new Office Hours and click on the Office Hours tab itself to see all the different offerings. So Chris knows a lot about the database. I know about PL SQL. We can handle a number of questions on Oracle database, but you have experts across the entire sweep of the technology that can answer your questions, and they're the ones who are either managing those products or building those products. So make sure you sign up for lots of Office Hours sessions, and hopefully we'll see you soon. Thanks for joining us. Take care. Happy coding.
Bye-bye, everyone. Thanks.